once again, welcome back. Just a very quick intro here. I just wanted to put this video in context with everything else. We have tried this reaction before. In the previous episode, we had some old ethylene glycol and we had made this cyclopentanone before, and we attempted to make this compound which we need overall for our Cubane synthesis, referring to it as a Ketal. We tried this before and it didn't work. There was lots and lots of comments. A lot of you had a lot of very helpful suggestions on things I could do a lot better for this reaction, so we're trying it again. I'm out of this compound, so we have to make this again. I'm pretty much out of ethylene glycol, so we have to make this or extract this. The toluene needs purification, so I've got to purify that. We need to purify our toluene, we need to make more cyclopentanone, we need to gather more ethylene glycol, we need to do all this reaction, and then we need to do a vacuum distillation. We need to do it all, and if you're confused by anything that I'm going too fast, it's probably because I've already done a whole video on it, such as this is for cyclopentanone. Everything is easy with a little bit of hindsight, so yes, on the second attempt, we should be much better at this. Alright, we've got the distillation toluene underway. I've put some sulfuric acid in there and it's disgusting, so hopefully that'll take out a lot of the colour once again. It's coming over looking filthy, honestly, and that's a bit of a shame. It's fine all through here, so I don't know what's up with that. It's just black in there now, so hopefully we've stripped any non-toluene components out, you know, and I chucked away the first bit of the fraction of the toluene, so we should have a much more pure solvent than what we had before. We've got the cyclopentanone. Is it? Cyclopentanone, yes, that's it. I keep forgetting its name every time. I was going to run this distillation at the same time, but I remembered I only have one pump now. I mean, I have two pumps, but I lent one of the pumps out to a friend for his home brew distillation, so that's a noble cause. His rum tasted awful, but I'm hearing reports that his vodka is better than his rum, so I will reap the rewards of that eventually. Alright, things are working much better with the fractionating column in it compared to last time. We're not getting nearly as much acid over, looking much better, so we'll probably get much better yield compared to last time, so things do improve on the second run. The catch with the fractionating column is really the speed. It's so slow. It's been hours. This is going to be another one of those times I pack up in the dark, isn't it? Going to be late for dinner, but at least the yield will be higher. So much yield, I am so late for dinner, my lord. Look at that. Don't look at that pentagon. That's the worst pentagon I've drawn in my life. Yield. Alright. It's not even late at all. Not even... Oh, God, I'm hungry. One thing to notice is the lack of acid that's crystallized out here. In our last synthesis, we had a lot of acid crystallize out of this step, but it looks like we've done the conversion much more efficiently this time, and there's not so much acid coming out, so we're not going to have to use so much sodium carbonate for the neutralization, but we'll still have to add some because we want to phase separate the water here. Distillation of the cyclopentanone. After we've got that water fraction over, we've lost a little bit. That's a fraction with the water in it. It's like 50-50 water cyclopentanone, but this fraction now is water free. It's coming over 126, so it's great. Oh, the thermometer's a little low. Yep, just like last time, there's a tiny little bit of sort of tarry stuff at the bottom, and we've let it go on for just slightly too long, so the top you can see is a little bit more yellow than the bottom, so it's just starting to yellow come over, so instead of being perfectly clear, we've now got a little bit of yellow. All good, once again. I just like turning on the camera and praising how good I'm doing. It's just like, yeah, look at me go. Alright, that's the update. Cool, thanks. And here's our yield. We got 114 grams, which is a 72% yield. So we started with 275 grams of adipic acid rather than last time we started with 200, I believe. A lot better than last time. It's a lot drier too, by the looks of it. The last one had the odd water droplet down the bottom. I still don't think it's completely dry, but there's no water droplets visible in it. Yes, fantastic, fantastic. All right, what else do we need to continue this on? Final piece of the puzzle is our ethylene glycol. So we have here some car coolant. It's a concentrated stuff, so there's not much water. It's pretty much all ethylene glycol. There's a little bit of something else in there, according to the MSDS. We're just going to distill the ethylene glycol out. The water should come over first. There'll be residual water. The difficulty with this is ethylene glycol tends to bump quite violently from previous experience because it's got a boiling point of 199. Quite a high boiling point. So we've got strong stirring, and I'm going to put some of the magic ingredient in there, which is sand. And hopefully the sand, as well as strong stirring, will prevent a lot of bumping. I think I might run a short path condenser anyway. Crank out the short path. Hopefully we don't get any of this dye over because it is ludicrously green. Okay, I forgot how short this short path condenser is. I know it's got short in the name, but like, how am I attaching a flask to this? Doesn't reach over the side of the Fucking broke it, didn't I? Alright, this is going fine, honestly. Yeah, 200 mils or so. A bit of water that came over first. We were very conservative. You know, I'm just checking away all this 100 mils here, really. Even though there's probably less than 10 mils of water in it. Everything is going all fine. Alright, we have everything assembled. We have our hobby car fuel, which we re-distilled and is somewhat dry. Decomposed food preservative, distilled, and it looks all good. We've got a heap of that. Our car coolant, which we've distilled. I'm not sure it's dry, but we'll do that in a second. And we have our drain cleaner, which we're going to use as is. I think we're only going to add a tiny amount of the drain cleaner to our hobby car fuel. I'm going to say maybe like 0.2 mils, like 6 drops. And I reckon we'll use all of the hobby car fuel and the car coolant in excess to the decomposed food preservative. Apart from the change in amount of sulfuric acid compared to last time, another major change we're doing is the order in which we do things. So what we're going to do is we're going to reflux the toluene and the sulfuric acid first in the Dean Stark setup to form the paratolusulfonic acid in situ first, and then we'll add our reactants. And that way we're not exposing the cyclopentanone to the sulfuric acid directly. That's really what I think drove all those side reactions that ended up with our reaction turning into tar. Maybe we'll dry these out a little bit more so when we add them in, we have no water, and any water we create from then it will be just from the reaction, and it shouldn't interfere with things too much. I'm not sure that makes sense, but we're just going to go ahead and do that. It also allows us to see how much of the tar is coming just from the toluene, because we've done a sulfuric acid wash. I distilled it over sulfuric acid. Each time it you know, turned to color and went a little bit tarry. So hopefully, having distilled it over sulfuric acid, there isn't much of that left, whatever is in the toluene that's causing it to tar up in the presence of acid. But no promises. Alright, so while we're refluxing the sulfuric acid and the toluene, why don't we pre-dry our 2 reagents with some molecular sieves. If we really dry out our 2 reactants before we add them into the toluene with the paratolusulfonic acid, it won't shift that equilibrium back to form sulfuric acid too much. I have quite a few molecular sieves in various states of dryness and cleanliness, because I tend to reuse sieves, which is something a real lab doesn't do, by the way. A real lab sees it as disposable, but I don't run a real lab. I run a terrible lab in a shitty shed, so I reuse my sieves. These ones are clean. They're also dry. I just cannot get the lid off the jar because they were dry when I put them in the jar. You can see that vacuum thing is down, and now I can't open the jar. So I will spend the next couple of minutes trying to open this jar. I'm not going to film myself struggling to open a jar because that will make me feel insecure. Actually, no, these sieves reek of sulfur. That's probably why they're in this jar. Probably because I can't bring myself to throw them out, even though I should. So we're going to use this jar, which has dried written on it in very scrubbed off text. So not the most promising, but we'll re-dry them and at least they don't reek. So it's a start. Alright, I preheated these in the microwave and quite a bit of water came off. They're very hot, but to get the last of the water off, I'm just going to put it under a bit of mild vacuum. I haven't really done this before. Don't tend to use sieves too much. I have this running joke that every time sieves appear in a video, the video doesn't make it to air. And I've made that joke at least 3 times now about the running joke and the things not making it to air, but that joke's never made it to air either. And I'm fairly sure I've made the joke about that joke not making it to air before, but it's just never made it to air. So we're at least 3 layers to 4 layers deep at this point. See what happens when we chuck this vacuum on. Alright, it's been cooling down under the vacuum for quite a while. It's still a little warm. Let's start weighing out our reagents. So we need ethylene glycol and a cyclopentanone. I'm just going to mix them together and put them over these sieves for just a little bit before adding them to our flask, which is looking concerning, but we'll get back to that in a second. so we have our two somewhat dried reagents together, and they needed to be added to our solvent and acid and refluxed. Our solvent and acid is looking, I mean, it's bad, but it's not as bad as expected. And oh, I can't believe I'm saying this, but hopefully the fact that it's tied up on the sides there means there's nothing left to react with things. And I've turned off the heating a little while ago, so it's cooled down slightly enough so I can pour some stuff in. You can see that's one nice even layer. So we don't have any raw sulfuric acid in there. Should be nice and dry in that flask. Maybe I won't add all of it at once. Let's add half of it or so. See if it all tars up instantaneously, in which case we shouldn't really add the other half. Maybe save it for a better day. Oh, I forgot to press record. Just pretend I poured half of this in there and that you saw that and it was good cinematography or whatever. Fucking doesn't matter. Whatever. Taking the flask off the heating, look at that. It's been heating for a couple of minutes, but why is it phase separated? There's not that much water in there. There's no way there's that much water in there. That's not a good sign at all. Why would it do that? Fuck me, what can we do? Alright, well, we're supposed we just gotta heat it and see if it unphase separates. But, fuck. Phase separating implies that there's a lot of water at the bottom, and that's separating from the toluene, because the ethylene glycol and the cyclopentanone should all dissolve in the toluene fine. So, but there's heaps of stuff. Maybe a little bit of water could cause the ethylene glycol to phase separate out. Maybe the ethylene glycol just doesn't want to dissolve initially. I don't like it. Don't like it at all. Alright, let's, lambs to the slaughter. Let's go. Yeah, you can still see that's a little bit translucent, whereas before it was really, really black and disgusting. So it looks much better than it did last time. So yes, I'm just going to wait for this to cool down, and then we're going to quickly get to the sodium hydroxide washing steps, the neutralization and the drying out, and then we'll do the vacuum distillation another day. Everything is cooled down. We've got the sodium hydroxide, just a weak solution there. And we've got some saturated sodium chloride. I don't think all this solution is going to fit nicely into my set funnel at the same time, so we might have to do it in portions. Other than that, it should be alright. Well, apart from the fact that I'm going to be very late for dinner. Once again, yeah. What the fuck is up with this bottom layer? What is this? Alright, it's a beautiful day. Got my cup of tea. It's wonderfully sunny and it's a good day for vacuum distillation. In other good news, our product doesn't look like it's decomposed significantly in the week that I've left it here. Always nice to see. I was a little bit worried about it being over the sieves, but we'll just filter the sieves off. We've got a little bit of cotton there. Alright, this is a vacuum distillation, so we have to talk about pumps. Last time we used our eBay 12 volt vacuum pump and it wasn't very good. There was quite a few suggestions in the comments of how we could improve that setup slightly, because I'm pretty sure all of you agreed it wasn't a very optimal setup and we didn't get a strong enough vacuum for what we needed to do. Saw quite a few comments suggesting different pump types I could buy and acquire and do it all. They're really helpful. Shipping out of China is especially slow, and that's the only source of cheap pumps. Generally, I can get some stuff locally. A couple of suggestions though were to just use my big pump and stop being such a wuss about it. I've got a very good pump. Sure, I like to protect it, but I might as well bloody use it. I got to stop, just being a wuss about it. It might get some toluene sucked into it, but it's an oil-based pump. It'll cope. It's built to cope. Even if the whole thing gets sucked in there, I could probably just replace the oil and it'll be fine. There's no point having a good pump and just not using it. So we're going to use it. We're not going to crank it all the way up to max vacuum, because that's quite a lot. This is what adjusts vacuum pressure in this line here. We've got a trap of sorts here. It's not an excellent trap, but I'll fill this up with ice. It's not that cold, so it won't do that good. But it'll do something, I'm hoping. It's leaking oil. It's still leaking oil. I never fix that leak, so it's slowly leaking oil. I've topped it up, so it's fine. It's got enough oil in it. Yeah, all right, let's set up the rest of this apparatus. All right, a lot of working parts to this, but I reckon we're good to go. Thermometer's in, stirring on, stuff's cooling down, condenser water is flowing. Got some calcium chloride in that ice there just to help reduce the temperature a little. Let's turn the pump on. All right, this seems surprisingly pleasant. Nothing has gone catastrophically wrong. There's even a hint that that's kind of even nearly boiling already. So, hey, we might actually be able to pull this off, much to my own surprise. Levels of yellow, they're getting stronger. It's getting yellower. I think that's just because we're removing the solvent from whatever the yellow thing is, but still, it's never nice to see. Still solvent coming over at 40 degrees. We're nearly there, I think. Oh, I don't know, but hopefully we're nearly there. I think I really am abusing the pump a little. You can see some toluene in the line here, so that's getting sucked into there. Doesn't look like it's leaving. This trap is doing its job, but I put some ice here as well. I think we are really sucking some toluene in there, but I don't think it's a big deal. But if I had easier access to dry ice, I could, make a much colder trap, and that's what a proper lab would do. But as I often point out, I'm not a proper lab, and I don't have nice access to dry ice. So, yeah, we have to make do. Rising in temperature a little. We're at a nice stable 40. Now we're at 45, so to see if this spikes too much more, we'll have to change out the flasks and then start collecting, hopefully, product. Hopefully it's not so yellow. It's very dehydrated piss colour at the moment. It's never what you want to see, either in your piss or in your bloody flasks. Over the flask. This is the first fraction. We got a little bit before, but I put it back in the bottle of solvent. So because we use like 200 mils of solvent, that's only like 50 mils. So the rest I put back already. We got the second fraction. I changed out the flask, and when I thought it sort of changed, but I'm more confident now because the stuff isn't boiling over. The pressure's the same. It's not boiling at all actually. So now I reckon the stuff in our flask is really what we want. So we've just got to distill this last bit. I'm not sure what temperature is going to come over. This came over at 30 to 40. This came over to 40 to 55, but it's probably still just solvent. But now we're into the good stuff. Taking a fourth fraction with this last little bit that's in the flask there, and then I'm going to pack this up very quickly because it's going to rain and I'm due to be somewhere else and I'm already late. So it's struggling to come through the column now. There's not enough material left, but that's all right. There's only a couple of mils, but we're getting a couple of drops here. More product, and excellent. You can see actually the pump oil is overflowing here because it's so full of solvent that it's got more volume and is overflowing. So forgive me, I have sinned. Sorry, pump. Here we have 4 fractions and they all look identical. At this point, if this was a good lab, I'd run an NMR to determine the composition of each of these fractions. This is our product, or if it's all solvent, or if from here is our product. We don't have that, so we've got to think of some analytical techniques of our own, determine if there's any difference between all these fractions. So what have we got available? Not a whole lot, honestly. So to begin with, they definitely do smell different. This one tastes like... Not tastes. Oh, I'm not going that far. This one smells like fuel, really. I mean, sort of a little bit sweeter than the classic toluene smell. Yeah, I'm probably imagining that. Whereas this smells a lot more decomposed. That's not a real smell. It's quite a distinct difference. It's not telling us that these are different chemicals completely, but it's at least telling us that there's some difference between the samples, potentially. Alright, that's a start. What else have we got? So I have 3 drops of fraction 1 here, and we're going to light it on fire. Toluene burns with a very orange flame and a very sooty smoke, which it is doing. Because it's aromatic, it's got no oxygen in the structure, it doesn't burn cleanly at all. And that is a typical toluene flame, no surprises there at all. Alright, we've got 3 drops of the 4th fraction in there now. It's a new bit of alfoil, and we'll light it on fire. And see, that is burning just a little bit cleaner. A touch cleaner. Wasn't very conclusive for my liking. Alright, I've done some thinking, and the only way I feel like I could be convinced that it's our product is if we have a nice boiling point separation between the toluene and our product. And we know there is one. We know that the boiling point of our product is a lot higher than toluene. We don't know what it is, but toluene boils 110, and our product is a lot higher than that. If we just have an oil bath here, and we heat this up to 115 degrees. So it'll be above the boiling toluene. If it's all solvent, it'll all boil off, and if it's our product, it should stay behind, and hopefully it shouldn't decompose under that heat. Alright, look at that temperature, and look at the lack of boiling. Even if I turn the stirring off, there's one floaty in there. God damn it, how does that happen? But there's nothing. No boiling. So, why don't we be a bit over the top, and I'll put a thermometer directly in that solution while it's heating there. If there's any toluene in it, it can't get over 110 degrees, because that's the boiling point of it. There we go, 130, 140 degrees. It's so hard to see that on camera. This is such a cheap thermometer. There we go, there it is. It's accurate enough, I think. I have tested these ones before, and these ones aren't too bad, but it's definitely over 100 degrees. It's not boiling. Look, I'm happy with that. I'm damn happy with that. Hell yeah, let's cool that down, bottle it up, and actually call it a bloody day. Another property we can test pretty easily is density. We have here a 10 ml cylinder, so we can measure out 10 mils and see how much that 10 mils weighs. If it's all just our cyclopentanone Ketal product, then we expect it to be 10 grams, because the density, according to the source I saw, was 1.03 grams per mil. Alright, that's bang on. I didn't actually know if this was going to work or not. We're right on top there. Yeah, that's beautiful. If it was ethylene glycol or cyclopentanone, we'd see a very different density, but this is bang on. Well, once again, not bang on, but it's my level of perfect, which, as you know by now, is much lower than most other people's version of perfect, but that's how we roll here. And here it is. Here's our yield. A yield of 44 grams. Amazingly. And of course, the moment you've all been waiting for, I did say people could put bets on, and I'd give you $2 Australian if you correctly guessed our percentage yield when we got it. It was a couple of videos ago. So 44 grams gives us a percentage yield of 31%. So congratulations to Mark and Corbin for correctly guessing 31%. I will PayPal you both $2 Australian. I feel really bad for the people that guessed like 32% and 30%. You missed out. You just weren't on it. You just weren't on the same levels that Mark and Corbin were. Given the fact that most people guessed somewhere between 1% and 10%, and not many people guessed above 10%, I'm bloody well happy with 31%. I'll take it. Anyway, well, see you next time. Thanks for putting the bets on. Gambling. Is this illegal? I'm not sure if this is illegal gambling. Oh well. Back out into the sun. Oh, cat, what have you got? Oh, don't bring the rabbit inside. Oi, oi, do not bring the rabbit inside. What have I said?